Hello, my name is Brighton Cox, and this is my Physics 2211 Lab 3 presentation. So, my intro, my first bullet point is just kind of restating what the instructions of the lab were, and the purpose was to find the mass of the black hole by analyzing a star's orbit, and we use this information to find the initial velocity our ship must have when it leaves the surface of the planet to fly around the black hole without crashing on the planet or the black hole. Some fundamental physics principles that are present at this lab are Newton's second law, and gravitational force. As a brief preview, we found out that the mass of the black hole was 6.52 e to the 33rd, and the initial velocity of the spaceship must be negative 6.45 e to the 6th, 6.16 e to the 6th, 0 meters per second. And some physics principles that were used in this lab were Newton's second law of motion, aka the momentum principle, and its formula is right there, gravitational force, and its formula is also right there. We also used the velocity update formula and the position update formula, which we've been using all semester, so we're pretty comfortable with those. Systems and surroundings. During part 1 of the lab, the system was a star, and the surrounding was a black hole. The mass of the star was 2 e to the 30th. During part 2 of the lab, the system was a rocket ship, and the surroundings were the black hole, the planet, and the star. Phase 1 procedure. The velocity of the planet was randomized to create individual values based on our Georgia Tech emails. The mass of the planet was given to us to be 2 e to the 30th grams. We were also given a time, 1 day, and we used that to calculate the net force acting on the planet from the randomized velocity in the parallel and perpendicular direction, and we approximated the mass of the black hole. Finally, we took the average mass of the black hole from all 506 timestamps we used. And then phase 1, some of our code right here. The initial conditions of the experiment were the mass of the star, the gravitational constant, and the change of time. And you can see some of our code right here, how we got, especially the last 4 lines, how we got F net parallel, F net perpendicular, and the mass of the black hole, which is the last line. And then, yeah, you could just see some of the results we got right there from our code. Yeah, same thing right here. After running the code, we got the results, the F net parallel, F net perpendicular, and then the mass of the black hole, 6.52 e to the 33rd. And then phase 2 procedure, using the mass of the black hole, calculate the net force on the ship from the planet and the black hole. The net force is the sum of the two gravitational forces of the planet and the black hole on the ship. Use the net force to update the velocity and position of the ship to find an initial velocity that allows the ship to escape the black hole without getting absorbed. And then phase 2 right here, this definitely is more important and heavy on the code side. And then we found out that the initial conditions were going to be negative 6.45 e to the 6th, 6.16 e to the 6th. And then, yeah, you could just see some of the math that we did, some of the manipulating of the formulas. And then last 3 lines of code, you can see exactly how we got our initial position. And then the biggest thing I want to say, and we're going to get more into it, is that we kind of had to use trial and error to get some of our code, and that's just part of the process. Right here you can see how we got our ship to fly close, but then still escape orbit, and then some of the same things right here. That's the velocity vector, and the closest distance we got was 1.19 e to the 7th and 4.9 e to the 9th. So possible errors. Possible error that could have occurred during phase 1 lab is that I could have run the code for a longer time at smaller intervals to get a more accurate mass for the black hole. So I'm just saying that there's definitely more ways I could have gotten an even more accurate mass for the black hole, but I don't think it's big enough of a difference where it creates a huge error in the lab. It's just something nitpicky and small. Possible error that could have occurred during phase 2 of lab is that I may not have the exactly correct initial velocity of the rocket ship because I used GlowScript and I did trial and error on the given code to get my initial velocity. So yeah, I just kind of played around with it, see what would work, and see the smallest number that we could get so it could get close to the ship but not crash. And then lastly, what if / what does it mean? What if we wanted to orbit the black hole instead of escaping it? In order to orbit, the ship should have a smaller velocity to the planet, but the y component must be larger and the x component should be smaller and negative in order to avoid the collision. So as you can see to the left, we have our ship actually circling around and entering orbit, exactly what they wanted us to do. And we got this through trial and error again. And then the initial velocity of the ship is negative 0.5 e to the 6th, 7 e to the 6th meters per second. And then lastly, what does it mean? Since net force is proportional to acceleration, the net force in its perpendicular and parallel components are responsible for dictating the acceleration or rate of change, its direction, and change velocity respectively. So yeah, that's it for my presentation for my Lab 3. Thank you.